Alrighty, hello everyone. Thank you so much for spending your lunch hour with us today. I'm Lily Mullock and I'm the marketing coordinator for the Nature Conservancy in New Jersey. I'm very excited that you could join us for our second webinar as part of our Earth Month webinar series. Today we will be diving in, pun intended, to our freshwater conservation work across the state. Chloe Pearson is our freshwater science specialist for the Nature Conservancy, and she is our speaker for today. She'll be bringing us through today's topic, Flowing Forward, Restoring New Jersey's Rivers. Next slide, please. Before we begin, as always, I have to quickly run through a couple of housekeeping items. At the end of the webinar, we will have time for a Q&A session with Chloe, so please be sure to add your questions to the Q&A feature throughout the presentation. We have live captions enabled for this webinar. To access them, navigate to your Zoom toolbar and click on the button labeled CC Live Transcript. From there, you can turn your captions on or off. You can also adjust the font and size of the font and colors of the text as needed. And then you can also translate the captions to the language of your choice. And lastly, we will be recording this webinar. You will receive a link to the recording in a follow-up email that you'll expect to see from us early next week. Next slide, please. So today's featured speaker is Chloe Pearson. Chloe is our freshwater science specialist. She received a dual bachelor's degree in marine biology and environmental science from Roger Williams University. She also received her master's degree in marine biology from the University of New Hampshire, where her research focused on movement patterns of migratory fish. Since joining the Nature Conservancy in 2024, she has worked to complete the chapter's 10-year dataset assessing of the impacts of restoration in the Pollenskill River, with responsibilities spanning data interpretation, synthesis, and public communications of the results. More on that to come. And now I will pass it along to Chloe to get started with today's webinar.
All right, thank you, Lily. Hi, everyone. Thank you all for coming today. As mentioned, my name is Chloe Pearson, and today I'm going to be talking to you a bit about some of the freshwater work that we have going on at the Nature Conservancy here in New Jersey. Really briefly, to talk about the Nature Conservancy as a whole, generally we were founded in 1951. We have chapters in 50 states and 69 countries, and we have about 1.6 million supporters globally. And generally, the Nature Conservancy has a mission to conserve all the lands and waters on which all life depends. So that's where a lot of our work is going to work towards. In New Jersey, oops, sorry. In New Jersey, we were established in 1955. We have about 50 employees in this chapter, and we are based in Chester, New Jersey. And overall, we've got protected about 62,000 plus acres of land in the state. We are currently working both globally and in New Jersey towards global 2030 goals with focuses on climate, oceans, freshwater lands, and people. Even as a smaller state, New Jersey has ambitious targets to contribute to the overall 2030 goals. And today we're going to be talking about the work that specifically supports the freshwater goals as are circled on this slide. To start with, I want to just give a background of how New Jersey freshwater, specifically New Jersey rivers, are faring. New Jersey is the rivers in New Jersey are about 95% are considered impaired. We rank about second in the US for impaired waterways. So there is a lot of work to be done with the rivers in New Jersey. Impaired rivers are often affected by pollution from industry, agriculture, and combined sewer overflows. Pollution is a major issue for New Jersey waterways and will require massive and coordinated efforts to improve our most impacted rivers. The Passaic, for example, cannot be cleaned up without comprehensive funding and action from the U.S. Environmental Protection Agency and many other organizations. The Nature Conservancy is exploring urban forestry enhancements in Newark and Paterson to help ease some of the stressors on the Passaic. If you were unable to join our cities webinar last week, I encourage you to watch the recording for more details on our partnership efforts in those communities and on behalf of the Passaic River. But for today, we're going to focus on another major challenge to New Jersey's rivers, dams. In New Jersey, the New Jersey Department of Environmental Protection Bureau of Dam Safety regulates about 1,700 dams, with many more not recorded. Landowners are responsible to maintain most dams or maintain these dams, with most of these dams no longer serving their original purpose, and a lot of them are getting quite old. A lot of these dams were built to supply water for agricultural crops, farm fields. Some of them produced electric or mechanical power for things like mills. And even further back, the water that they would back up would be a place for ice harvesting. But again, these are older dams. They're no longer serving their purposes, and a lot of them were not made with materials that were meant to last forever. So as these are starting to age, they become an increased risk for failure. And again, I mentioned that the landowners are going to be responsible for maintaining these dams. So as they get older, there's going to be more and more costs associated with maintaining them as that risk of failure increases. And that's going to be landowners anywhere from a private landowner, if you just have a dam on your property, to the municipality, to the state. In addition to the hazards to humans that these failures could cause, these structures also cause significant damage to fish, wildlife, and river function. We can generally prioritize dams for removal in New Jersey based on their hazard level and the amount of ecological gain that would be seen from removing these dams. So that's kind of what this graph is showing, is some of those prioritization ideas for removing some of these dams. In New Jersey, we have these specific freshwater goals, and a lot of this rotates around dam removal. Specifically, we hope to reconnect 500 miles of stream habitat. We want to remove 50 dams, which will help us reach that goal of 500 miles of reconnected habitat. And we want to generally measure success and facilitate further dam removal through the scientific findings of measuring the success of our dam removals that we are doing. Um, Why remove dams? I've already touched on it a little bit, but I want to go through 4 large reasons to remove dams, specifically the ecology, fish, recreation, and cost associated with these dams. Starting with the ecology, dams may look similar to natural structures, but they do not function the same way. For example, a dam may look like a waterfall, but waterfalls are natural. They don't cause sudden or dramatic changes in the riverscape. They allow for water to continue flowing rather than slowing it down. In comparison, the dams will interrupt the natural flow of water. They will pool water behind the dam in what we call an impoundment, and that's a term I'm going to continue using throughout the rest of this presentation. These impoundments may look like lakes. They may even be historically called a lake in the community, but they will not function ecologically as a lake. And they can actually worsen flooding as well. A lot of times these impoundments will be moving really slow. They'll increase the surface area behind the dam, which can cause the water to be warm. They will also, as it gets warmer, this will reduce the oxygen in these areas, kind of acts like a hot tub. They also will impound sediment behind the dam, so it makes the sediment not be able to wash downriver like you would see in a waterfall environment. Wildlife cannot adapt to these sudden changes in the riverine landscapes, which allows a lot of times for invasive species to then take over in these unnatural landscapes. Additionally, with wildlife not being able to adapt, they also are not able to pass these structures a lot of times. Particularly, we want to look at fish. A lot of times we talk about migratory species. These are species that are going to require freshwater habitats to complete some portion of their life cycle, such as reproduction. Migratory fish will need to be able to get up into those freshwater environments, and if the dam is in place, they're not able to do so. Even with fish ladders, a lot of species will not be able to pass over fish ladders. They are not necessarily an appropriate method of getting the fish upriver for every species. Outside of just being important for the fish themselves, these migratory fish also transport nutrients in from other habitats. A lot of times there's nutrients in saltwater habitats that we will not get as much of in the freshwater habitats, and they'll eat food in the saltwater habitats and then bring it up into the freshwater habitats and excrete those nutrients. This is very important, just transportation between these environments that is facilitated through these migratory fish. And if there's dams in place, they cannot do that movement. Additionally, fish, not even specifically migratory fish, but fish in general, need to be able to move throughout the river. They will help facilitate transport of other critters, such as the freshwater mussels. The freshwater mussels will release what are called glochidia. These are parasitic larval stages of the mussels that will hook on a fish, and then as the fish moves upriver or around the river in general, they will fall off in a new location, which helps the spread of these mussels as well. Additionally, dams are a big barrier to recreation as well as they are hazardous to people. There are actually 50 dam-related fatalities annually in the US. They look very deceptive, that you may not be able to see the strong currents or things that are around a dam, and then you get caught in them and it can be fatal. Additionally, they're dangerous to recreate around the dam from this purpose, but also if you're, say, kayaking or something like that, if you come across a dam, you can't necessarily just go over the dam. It's not safe to do that. You'd have to pull your kayak out, and then go back in at another location, which is just not as nice to be able to go down the river completely as you would be in an open river. Many dams, as I mentioned, are also aging, which causes an increased risk of failure. This can be dangerous on a population level if there is a breach or a failure of the dam. It can cause a lot of water moving downstream quickly. It is expensive but important to maintain dams, and owners are legally obligated to maintain them. And as they're aging, there becomes more and more maintenance involved with this legal obligation. This is where we start to see everyone mentions that dam removals are costly. They are. This is something that we do note, but they are a one-time cost rather than continued increased maintenance of an aging dam. Plus, a lot of times, as I mentioned, these dams are not serving their purpose anymore. They have negative impacts on ecology and recreation, so it really just makes sense to remove them rather than maintain them. Now that I've talked a little bit about the importance of dam removal, I want to go in and discuss a river that the Nature Conservancy has really been focused on. The Pollenskill is a river in northwest New Jersey that was identified as a high priority for ecological gain through dam removal. It is approximately 42 miles long and feeds directly into the Delaware River. It's actually the third largest contributor to the Delaware River in New Jersey. And on this map, I just want to point out where the pollen scale is. You can see it marked in dark blue in that northwest corner. The watershed itself is in green. You can see it's in Sussex and Warren County. And then it feeds into the Delaware River, which is that kind of brighter blue color along the edge of New Jersey. Before the Nature Conservancy started working in the Pollenskill, much of it was already in what we would call good condition. About 3/4 of the floodplain was in natural cover. And a floodplain is a really important habitat immediately adjacent to a river. The natural cover is forest plants. So you can see in this photo, we've got a lot of trees and stuff that are going to be kind of hanging over the river. This will help provide shade for the river and also help with erosion. As the name suggests, these areas will flood as the river, if there's a lot of rain and the river is high. And if there's not these forest plants in place, then when the river goes back down, it'll take a lot of soil with it. So having these plants or these areas be in natural cover and having these plants present will help to prevent that erosion. So having 3/4 of the floodplain in natural cover was really great. Additionally, over a quarter of the watershed was already protected. And this area was really popular for things like fly fishing, birding, hiking, hunting, kayaking. There's actually rail trails that run alongside the majority of the Pollenskill, making it a really popular area for recreation. Though we consider the Pollenskill to be good prior to our work in this area, there were still problems, particularly ones stemming from human impact, particularly those barriers that we've been talking about, like the dams, which will then cause impaired water quality, and overall there was a disconnection from the floodplain in certain areas. With this in mind, the Nature Conservancy worked with local partners to create the Pollenskill Watershed-Wide Initiative. This program ran for 10 years, monitoring watershed conditions alongside restoration efforts from 2016 to 2025. This directly tied into our 2030 goals at the Nature Conservancy, specifically looking at barrier removal, connectivity, and the idea of measuring our success. Throughout the watershed, we did data collection at each of these kind of yellow points that you can see on this map. Each of those is a site that was sampled at least once within the 10-year period, with most of them being sampled annually, or many of them being sampled annually. Having sites throughout the watershed provides insights into the overall health of the watershed as we go through time. Additionally, over the 10 years, TNC facilitated the removal of 4 dams at 3 sites. First, the Columbia Dam and its remnant were removed in 2019. That's going to be the circle on the left. You can see it marked Columbia Dam. That was going to a large dam that I'll talk more about today, as well as a remnant dam that was already breached, talking about failure due to aging infrastructure and things like that. We also removed the County Line Dam, which was further upstream. That was in 2020. And finally, we just removed the Paulina Dam in 2024. We did have sampling sites that were very strategically placed alongside these dam removal sites. And the idea of that was that we would strategically monitor those sites with the removal and determine what changes may have occurred, if there were any positive effects from the dam removal by looking at our monitoring data. So generally, why do we want to have this idea of monitoring success, and why do we want data specifically? Generally, we want to report findings in kind of standardized terms. This allows us to reduce personal biases. What one person might consider good might not match what another person considers good. If we have data that we can compare to preset standards that everyone else also uses, we can really properly define changes in the watershed and define what good looks like in the river. So we can very empirically state there was this amount of change and this was a good thing to with the restoration effects. The data that we collected is in kind of 2 categories. The first being physical data. The bulk of our data here comes from our physical water quality monitoring. This was continuous monitoring of parameters such as temperature and dissolved oxygen. This data was collected with in-stream sensors. You can see a couple of them on this slide here. These are going to be put out in the river from April to September for all of those 10 years. So months every year for 10 years. These sensors will take a snapshot of conditions in the water, so they're actually under the water, every 15 minutes. That allows them to record even when we're not there, which just gives us more information about the watershed. It's not reliant on it being daytime, low flow conditions, things that we would need to be able to be out in the water. Overall, this data is over 1 million data points, which paints a really clear picture of the conditions in the river throughout those 10 years. We also looked at biological water quality within, or biological measurements of water quality within the river. The first one being benthic macroinvertebrates. These are essentially water bugs that live on the bottom of the river. This will include organisms like crayfish and mussels. If any of you are anglers, you're probably familiar with stoneflies and mayflies. These are going to be the things that the fish will like to eat and be kind of that structure in the food chain. These macroinvertebrates are also going to respond to environmental impacts, such as the temperature and dissolved oxygen that we're measuring, but they will combine those kind of factors into an overall sense of what the water quality is in the system because they're experiencing all of it, not just temperature, not just dissolved oxygen. Some species of macroinvertebrates are also sensitive to things like pollution or water quality factors, so we can specifically look at what species are present and their abundance to give us a proxy of what the water quality is like in that area. If there's a species that's sensitive to pollution and it's missing at one of our sites or one of our sites, we could state that that site is impaired. There's something going on there, and we can see that through the macroinvertebrate communities. And again, this is standardized. Everyone in the area is going to use that same ranking scale for these macroinvertebrates so we can compare kind of apples to apples with the data and what we consider good with these bugs. We also looked at migratory fish as another biological proxy of water quality. In the pollen scale, the species of interest are American shad, American eel, and the sea lamprey. The sea lamprey is who's imaged here on this slide. These guys are actually really cool. They never develop jaws, so they are parasitic and they drink blood from other fish, and they'll use kind of their teeth to grip onto those other fish and will drink the blood kind of like a little vampire. The fish data was collected by partners using 2 different methods, the first being environmental DNA or eDNA. When fish are in a system, they are going to be shedding their DNA through mucus, scales, other secretions or excretions, kind of like how our skin cells end up in our dust. It's kind of gross, but true. So generally, we can then collect water samples and then run analyses to match the DNA in those water samples to a known DNA signature. So we can say, okay, well, we know what a DNA signature for a sea lamprey or an American shad looks like, and we have that in our water samples. This allows us to detect if the fish are in the system without actually catching them. So this is really good for species that maybe migrate at night when we can't be out sampling. They maybe don't handle being held well. A lot of fish can be really sensitive to being handled. So generally, this means that we don't need to catch them for this method. The other way of sampling that was performed is called electrofishing. As the name suggests, this involves the use of a little bit of electricity. We send out a little shock into the water. This slightly stuns the fish, allows them to be more easily caught, and then they'll wake back up. It's very temporary. It's not going to hurt the fish, but it does make them easier to catch, particularly if they're good at hiding. So then we can look at them and identify what the fish are, do some measurements, things like that, and release them. So now that I talked about the data that was collected, I want to go back and talk about, as I mentioned, these sites are strategically located around our restoration efforts. So I want to go through and discuss some of the findings that we had with our restoration and these dam removals. I want to start with the Columbia Dam, as that was the first dam that was removed in the Pollenskill. This dam was about 330 feet wide and 18 feet tall, which is a pretty large structure. And it was really prioritized for removal due to its location in the Pollenskill. It was only about a quarter mile upstream from the connection of the Pollenskill and the Delaware River. So the removal of just this dam opened up 20 miles of habitat, both in the main stem of the Pollenskill, so the main part of the river, as well as the tributaries. So that's why this one was really prioritized because the fish that were trying to get up into the Pollenskill were pretty much immediately bumping their nose on this dam and not able to get further up into those freshwater environments. The Columbia Dam had been in place for over 100 years. It had a large impoundment behind it and a lot of sediment that was backed up. So it was actually removed in stages to account for that. So it was notched, which is what's shown in this picture here, in 2018. The impoundment was allowed to dewater and go back to more of a flowing river system before the full removal in 2019. This is a pretty standard way of handling one of these larger dam removal projects with a lot of that impounded area. As the impoundment dewatered and riverine conditions were restored, it exposed floodplains that had been completely submerged. The plants that are going to be in the floodplains, while they like to be a little bit wet, they can't really survive being fully submerged. So the area that was exposed was completely bare when it was brought back up. And I mentioned before that these are really important habitats for things like erosion, shading, all of these other features. So when the floodplain became exposed, we then went back in and replanted these floodplains with about 12,000 trees in the floodplain that was exposed just from this one dam removal. And this was intended to reestablish that important habitat and ecological function. We also did bank grading with this removal process. We wanted to make sure that there was gentle slopes on the banks, as again, that will help with erosion. If there's really steep banks, they'll often get undercut by the water and will pull a lot of sediment and bank away. And then there was rock veins put in, which will allow for pooling water for fish and other organisms to rest in. And that's what's shown in the picture here. You can kind of see that rock almost jetty coming out in the water, and there's going to be some pooling water behind it that the fish can kind of go hang out in and then go back into the more flowing water. So generally, we collected data around the Columbia Dam removal site annually. I mentioned previously that part of the benefit of the data collection is that comparisons can be made to existing standards. For this project, we compared to New Jersey Department of Environmental Protection surface water quality standards for temperature and dissolved oxygen. Generally, a lot of times these standards are based around the ability of a system to support a species of interest. So for New Jersey, we have all these standards built around trout. The Pollenskill is classified as a trout maintenance river, meaning that it can support trout populations all year round. So generally, we want to continue meeting the thresholds for temperature and dissolved oxygen that will support those trout all year round. So to meet this standard, we want to see temperatures not exceeding 25 degrees Celsius and dissolved oxygen staying above 5 milligrams per liter at any time. For the organisms in the pollens kill, the main concern with temperature is it getting too hot. So for this graph, we took the daily maximum temperature for the hottest months, June, July, and August, and then averaged those daily maximums for each year. We do this to represent the theoretical worst conditions for each year at each site, since the hottest temperature is in the hottest months. Generally, what we see on this graph is kind of vertical stripes of color representing changing conditions in each year. We do see temperatures that are kind of sitting at that threshold, but we're not seeing a ton that are going over that 25 degrees threshold. But we do see some years that are a bit hotter and then some years that are a bit colder, rather than really changing conditions in relation to the dam removal. Water temp conditions such as temperature can be a bit tricky because they are heavily influenced by other factors such as air temperature. We did do further analyses with this data and did determine that the dam removal did have a positive cooling effect on the sites around the Columbia Dam, but a lot of times what we wanted to know is that these changes can be masked by environmental variables. Generally, it's suggested that sampling be done for multiple years after a dam removal, and this shows one of the reasons why. Having multiple years of data allows us to determine what changes were actually coming from the dam removal rather than effects of environmental factors. This graph is really similar to the previous one, but for a different parameter, dissolved oxygen. Our concerns with dissolved oxygen are inverse to our concerns with temperature. Low dissolved oxygen is bad for organisms. Therefore, we took the average minimum dissolved oxygen for each day in June, July, and August and averaged them for the year. They do have a very temperature and dissolved oxygen have a very inverse relationship. If the temperatures are too hot, the water cannot necessarily hold as much oxygen. So that's where we get those. Still, we want to use those hottest months are going to be those low dissolved oxygen days. Generally, what we see looking at that trout maintenance threshold of not wanting to see less than 5 milligrams per liter at any time, most of our sites are going to be meeting that threshold. They're going to be above 5 milligrams per liter, even at their minimums. But what we do see here is one of those sites that is labeled lower impoundment. This is an area that was in that kind of pseudo lake environment that was above the dam. Um, this was only sampled after the dam was dewatered, as we could not, uh, all of our methods are for walkable reaches of stream. We couldn't necessarily sample in kind of that more lake environment. But as time went on, we saw generally a shift from being kind of right around that threshold to having a little bit more dissolved oxygen at this site. And really, the important part of this is also that we see a stabilization of the dissolved oxygen at this site. 2024 was a drought year. And again, those temperatures and amount of flow and all of these things are going to have an influence on dissolved oxygen. Yet, even in a drought year, we're still seeing conditions at this site, which is a restored site, that are meeting those trout maintenance standards. So this is a really positive indication of the dam removal having a good effect on these impoundment sites. This also again shows the importance of doing multiple years of sampling after removal. If we had made conclusions in 2020, right after the dam removal, it would have been very different from what we see now in 2024 and even 2025 a little bit later as well. Um, Comparatively, while temperature and dissolved oxygen can kind of take years to show effects of the dam removal, migratory fish, on the other hand, are very quick and they returned very quickly to the pollens kill. They were found about 10 plus miles upstream really shortly after the removal. Specifically looking at American shad, these were a species of particular interest in the Delaware watershed and Pollens Kill. They are anadromous, meaning that they spend most of their life in saltwater but need to reproduce in freshwater environments. And historically, the Pollens Kill supported spawning or reproductive populations of American shad. With the dam removal, we wanted to see whether they would return and get further upstream, but they can be hard to catch. They kind of don't like being caught. So this brings up that idea of using that eDNA. This eDNA was collected by New Jersey DEP, Bureau of Freshwater and Biological Monitoring. This was done during 2022 to 2024, so all after the dam was removed. And what we did see was that American shad DNA was present at sites above the former Columbia Dam for the first time in 100 years. So this indicates that these fish are being able to go up the river now, and shad in particular do not cross dams. So the fact that we're seeing them above means that these rivers are now connected for them to be able to go up the river. Another species that we looked at were the American eel. They were sampled by the Academy of Natural Sciences at Drexel University, and they were sampled using the electrofishing method. They can actually get over barriers such as dams, but it's a large effort, so we would only see small populations upstream. American eel are the opposite of American shad. They're called catadromous, meaning that they grow up in freshwater and then migrate back to saltwater to spawn and then come back as juveniles to those freshwater environments. So those juveniles would be the ones having to get over the dam when it was in place. What we saw with the American eel sampling was this graph is showing the average number of American eel that were caught in each electrofishing sample at 4 different sites. And you can see the colors in this graph are matched to location on the map as well. The blue line in particular is the site that was downstream of the Columbia Dam. And you can see that before the dam removal in 2018, most of the eels were caught downstream of the Columbia Dam. After removal, there is actually what looks to be at first glance, it's like, oh no, they're declining at this site because that line goes drastically down after the dam removal. However, what we believe is happening here is that we have these individuals that were once sitting at one site down below the dam, and now they're able to use habitat at 4 different sites. So instead of actually declining, what's happening is they're dispersing. And so we do see populations at or abundances at those upstream sites increasing as the years go on. And particularly, we see this yellow site, which is the site that's right below the next dam upriver, which at the time of this sampling was not yet removed. We see that the abundances right below that dam were increasing pretty drastically. So not only are they using the habitat that's open up to them, but they're going as far up as they possibly could. Um, and now I want to look at those macroinvertebrates, which are going to be the food for a lot of these fish species that we've just been talking about. As I mentioned earlier, they're also often also used as a measure of water quality, as the species present predictably relates to the water quality. We can compare our composition of macroinvertebrate communities to set standards and get a score of poor, fair, good, or great, which you can see on this graph. Generally, the sites that we sampled showed good and excellent macroinvertebrate scores for most years, regardless of the dam removal stage. For now, I'm not going to look at 2025. I will talk about that more in a couple of minutes. But I do want to talk about this pattern of general decline in this shaded area, which is when the actual dam was removed. This is a pattern of decline that is often seen with dam removal projects. Often it's because of that sediment moving with the actual dam removal and construction and things like that. The macroinvertebrate communities will temporarily worsen during the dam removals, and then they'll immediately come back and rebound to those good and excellent scores. And that's exactly what we saw at this site. Again, kind of leading to that idea of needing to sample multiple years. We want to make sure that we're not looking in 2019 and going, oh no, the macroinvertebrate scores are declining. What did we do? In fact, it's just because of the construction going on, it's temporary, and then we go back up to those higher scores. With all of this data now, we want to make sure that we can share it and have others learn from this project just like we're learning from it. Therefore, we've been working to publish these results in a scientific journal. And this publication has been approved and should be out soon. So keep an eye out for that if you're interested in more of kind of the nitty-gritty of the scientific processes that I've been talking about today, giving some of those findings. And also, we generally saw improved water quality, improved connectivity with migratory fish, good macroinvertebrate scores post-removal. So in general, we consider the Columbia Dam removal to be an example of successful river restoration. The success of the Columbia Dam was then used to leverage the removal of a further upstream dam in 2023 and 2024, the Paulina Dam. And that dam was about 230 feet wide and 12 feet tall, making it a little bit smaller than Columbia, but still a large dam in this system. Pliny Dam was further upstream. It was the final of our 4 dam removals. It was the most recent one. There was one dam removal further upstream, but it was a much smaller one, the County Line Dam. This was only about 4 feet tall. But the removal of all 4 of these dams has now reconnected 45 miles of main stem and tributary habitat to the Delaware River. So this leads into those 2030 goals again. We've had 4 dam removals going towards that 50 and 45 miles of habitat going towards that 500. Just like Columbia, Paulina Dam was removed in stages with the notching in 2023 to allow for dewatering of the impoundment and then full removal in 2024. Additional restoration efforts were completed in 2025, so very recently, including again that bank grading to help with some of that erosion control and planting in the floodplain again to reestablish that habitat that is so important for those bank systems alongside the river. We had about 2,000 trees planted alongside the floodplains in the Paulins or alongside the Paulina Dam. Though we only have 1 year of data post removal of the Paulina Dam, there are some immediate effects that we can analyze. The first being the return of migratory fishes. We once again sampled American shad eDNA. It was collected in 2025 at a site above the Paulina Dam, and the American shad were detected. This means that not only are they using, or that they are using the habitat that was open, and it's very quickly they're using that habitat. We're currently planning to do at least 1 more year of this sampling, particularly because, again, I mentioned the importance of having multiple years of sampling to understand any additional factors that may be influencing what we're seeing. We also looked at the macroinvertebrates again alongside this removal. They once again scored within the good and excellent categories, but we didn't see the same expected decline in scores during the actual dam removal like we saw at Columbia. We think the difference between the Paulina Dam removal and the Columbia Dam removal in relation to the macroinvertebrates was related to the weather. During Columbia Dam removal, there was a lot of rain, meaning that the sediment that was getting moved out from the dam removal itself was getting moved downriver towards the Delaware very quickly. During the Paulina removal, however, there was a drought, meaning that a lot of the sediment was not moving quite as quickly through the system, and it wasn't moved until the next spring, kind of spring of 2025. And so what we saw, I said I'd come back to that 2025. What we saw is that in 2025, when we took our macroinvertebrate samples, we did start to see a decline, not only at Paulina, but also at those Columbia Dam sites, remembering that Paulina Dam was upstream of the Columbia Dam. So anything that's happening at Paulina Dam is also going to have an impact on some of those downstream sites with things like the sediment moving. So we do see this decline again at Columbia and a little bit at Paulina, but this is something that we expect with these dam removals, and similar to what we saw at Columbia, we expect those scores to go right back up after that sediment in movement in the river balances. But what we do know with this is just the importance of noting that everything is connected in a river system, and what we happens upstream, whether that's good or bad, is going to affect what happens downstream. Continuing that idea of everything in a river system being connected, I want to briefly touch on some of our other floodplain restoration work in the Paulins-Kill. I mentioned planting trees in the floodplains after dam removal, which was an important component of the restoration. However, we also planted trees in floodplains throughout the watershed with a focus in the upper watershed. Overall, we planted about 58,000 trees in the Paulins-Kill, which was a huge undertaking. And along this, what we call 4 mile reforestation corridor in that upper watershed, we planted about 17,000 trees just in that 4 mile stretch of river. This was an area that had been a lot of clear cutting for agriculture, leading to a disconnect again between the river and the floodplain. So a lot of this work was intended to reconnect those important habitats to the rivers. So then looking at kind of what's next for our rivers work in the floodplains, since I was just talking about it, we are working hard to steward those plantings. All of those trees, or many of those trees, were planted with protective covers to ensure that they don't just deer don't come through and immediately browse on all those little baby trees, as well as stakes to help them keep upright. We're going through now that these trees are getting larger and removing those protective covers and stakes from the watershed. We also recorded how well those plantings survived and are currently working on another paper focusing on the effects of the floodplain plantings, once again quantifying success and measuring success with our restoration efforts. TNC is also continuing to lead the statewide dam removal partnership to scale up dam removals in New Jersey. This partnership is intended to expand on dam removal through outreach, monitoring, policy, and funding. One recent project of the SDRP, the statewide dam removal partnership, is the Voices of Dam Removal video series on YouTube, which interviews people at all levels of dam removals, from municipalities to private owners to anglers. So I highly recommend, if you're interested, please go check out that video series. It's a really wonderful look at all the different voices of dam removals. Another main goal of the SDRP is to build capacity for these future dam removals through trainings. Generally, this helps us build towards that 2030 goal of 50 dams removed. I mentioned all this work in the pollen skill, but that's still 4 dams, which is awesome to get 4 dams out and 45 miles reconnected. But we have goals to remove 50 dams and 500 miles of river connected. So by scaling up who is able to do these dam removals and providing funding and training programs and things like that for people doing dam removals, we help build towards those overall goals. We've also worked to continue data collection and particularly with the American shad with the removal of the Paulina Dam. As I mentioned, we're going to be looking to do at least one more year of eDNA sampling to really better understand their return, as well as we were hoping to do juvenile sampling. And the idea of that is that if the hope of the American shad getting back into the river is that they are going to reproduce in the river. And we want to see whether or not they're successfully doing that reproduction by sampling the juveniles. If we can catch juveniles in the river, we know that they're reproducing and are creating new populations in the pollens kill. There's also a upcoming restoration project looking in the headwaters of the Pollenskill. At the headwaters of the Pollenskill is a historical site called the Hyperhumus. There was peat mining operations in the early 1900s, which dug out areas for about 75 years in this wetland habitat. What remains is shallow, hot, and slow, which causes things like low dissolved oxygen. Again, this is problematic for the Pollenskill as it is in the headwaters, which are the beginning of the river. As mentioned earlier, these rivers are connected, and areas downstream will feel effects from the upstream. So while I was talking about the effects of our restoration projects earlier, they're also feeling the effects of having this degraded habitat upstream. So restoring areas at this site, we hope to restore kind of throughout the watershed as well. And again, this restoration is upcoming. So then in general, for summation of everything I've talked about today, in New Jersey, we are really working hard to protect and improve our rivers. This will be possible through scaling up dam removals, reconnecting rivers, improving adjacent habitats, including floodplains, and nurturing partnerships and nature-friendly policies to help preserve and restore these very important habitats. And with that, I will say thank you so much for tuning in. I'm going to turn it back to Lily, who will coordinate some questions that I'll be happy to answer today.
Thank you so much for that incredible presentation, Chloe. As she mentioned, we are going to transition into the Q&A portion of the webinar. So we do have a couple of questions in the Q&A feature, but please feel free to add more as they come up. Any questions that we can't answer during this live session, we'll try our best to address them in the follow-up email that you will receive from us. Okay, so we did have a question about what was the fish species from the data collection page. And correct me if I'm wrong, Chloe, but that was the sea lamprey, I believe.
Yes.
Okay,
That
awesome.
was the sea lamprey, which are a species that spend time in both that freshwater and saltwater environments as well. They do migrate.
Okay, thank you. Let's see here. So in addition to man-made dams, there are at least two types of natural dams, beaver-constructed dams and windfall, that can block a stream very effectively. What are the pros and cons of these two compared to man-made?
So a lot of these natural environments do actually behave differently ecologically than the man-made dams. There's nutrient cycles that will happen in relation to beaver dams, particularly in terms of the beavers being present. The beavers will actually go through and help move things along and the help cycle some of that water through. So those will actually function nutrient cycle wise differently to those dam sites because we do have the presence of those natural critters that are going to be helping with some of those functions. Similarly, these windfall ones will also sometimes cause degraded habitat, but again, it's going to be something that critters can come through and mess with those trees and they'll essentially break down eventually and will eventually restore that flow to the river, or the river will start to go around it, which again, with the dams, the river also starts to try to go around the dams as well and adapt for it. And that's where we get these ideas of breach and failure. So generally, these natural Dams, they do cause sometimes some of those same conditions where we have some of those water quality changes, but the idea that they're natural and eventually may change in some capacity really makes a difference for those water quality conditions in the river.
Perfect. Thank you. What is the process for collecting eDNA, and why were American shad and American eels the species selected for eDNA monitoring?
eDNA monitoring, essentially the way that it was done, there's this cool backpack that you can wear that has a tube that sucks in a bunch of water with like a motor on your back, sucks in a bunch of water and it puts it through a filter, and that filter will collect, so you'll filter, I think it's about a liter of water in each sample. And it'll collect the DNA on that filter. And then that filter, we send it out to Rutgers and they will process chemically that filter and identify what DNA is present. So they have these standards that they'll use that say, okay, if this DNA strand is present, this is what an American shad DNA looks like. And we can essentially get yes or no on whether the DNA is present and how much of it is present as well. Um, the American shad were chosen for that eDNA process because it's a process that we don't have to catch them. American shad can be particularly hard to catch. They don't actually take to electrofishing well. They're a little bit hard to shock. They don't really react the same way as other fish, as well as they can be somewhat fragile to handle. So we wanted to be able to use a type of sampling that would be beneficial for everybody, the shad and us. We'd be able to see them without physically catching them. The American eel were chosen for the electrofishing. They're a little bit more capable of handling those shocks and being handled, as well as they're pretty good at hiding. So being able to get them a little bit more stunned and have them caught, they're very if anyone's tried to handle a worm, American eels are pretty hard to handle. So if they're a little bit stunned while you're handling them, it can make it a little bit easier. And those specific species were chosen for this project because they are those migratory species that used to be present in the Paulins Kill. They're very important for that transportation of nutrients and all sorts of things like that, but they weren't necessarily getting into the Paulins Kill. So by specifically monitoring those species, we're able to understand that connectivity to the Delaware in particular, rather than species like trout that may be also benefiting from being able to move around the river more, but they were kind of above the dam already.
Awesome. Thank you for that explanation. Let's see here. We have a question from Tom. Several destructive invasive species have been found in the Delaware, like snakehead, blue catfish, freshwater drum, maybe some others. Are you concerned that the dam removal on the tributaries will allow these species to get further upstream and cause problems in the tributaries? Is there any natural way to prevent such propagation?
The problem with invasives, it is something that we consider. However, a lot of times these invasives are things that people will like to fish for or will catch them. And so a lot of times they end up above the dams anyway, without the removal of the dam, because people will catch them and move them above the dams to kind of establish them to catch them. So like the snakeheads in particular, people like catching the snakeheads and they'll move them into areas that may have been blocked by the dam. So while the dam removal, it does facilitate passage for any species, and that would include the invasives, the presence of the dam is not necessarily blocking the invasive species like we would hope. So it's not necessarily going to further facilitate that movement that's already going to happen. And really, the natural benefits of the dam removal, a lot of times these invasive species will thrive in conditions that other species are not able to. So, like hotter conditions, lower dissolved oxygen, things like that. So, the removal of the dam and coming back to those natural conditions of the lower temperatures, lower dissolved oxygen, even if there are those invasive species presence, will give the other species more of a fighting chance to be able to stay in their niche and be able to handle it. So, that's one natural way to handle it. In addition to, if you do catch like a snakehead or anything like that, please do not release it, especially not in an area that you're not catching it in. But please don't release those species as well.
Awesome. Thank you. Is there a TNC preserve along this river we can visit and walk the trails near the river?
A lot of the preserve or the area that's preserved with like those rail trails that I was talking about, those are going to be state-owned land. There is a ton of area to walk along the river. There's actually two different rail trails. There's the Paulins Valley Rail Trail, I believe, and then there's one in the upper watershed as well. Because I don't know if the way the river kind of bends, there's the it goes a little bit horizontally for a bit and then the traditional river that we expect. So there's two rail trails kind of going like this. So I would highly, highly recommend checking out those areas. It is absolutely beautiful walking along those rail trails or biking those areas. And they are state-owned land so a lot of those will have like little parking lots and things like that that you can park in and walk.
Are sturgeon using the freed portions of the Pollenskill River?
Sturgeon are not going to be quite as far up the Delaware River as the Pollenskill is. They're going to be more in the lower portion of the Delaware River. I'm not as familiar with sturgeon use in the lower portion of the Delaware River, but I will say they are a species that we consider with any of these kind of removals and or at least that we would in the lower Delaware. Any of these species that are those migratory species are do have the potential to use any of these habitats, but they're not necessarily going as far up into the Delaware as the American shad, American eel, and sea lamprey are.
Thank you. We have a question from Dana. Have local communities been largely supportive of your efforts, or do you receive any pushback or hear concerns expressed?
I would say that we have kind of a mixed bag. A lot of times, we do get some pushback, particularly with people that don't understand why we want to remove the dam. And once we go through some of those things that I talked about, like the cost of maintaining the dams, the hazards of maintaining the dams, the fact that they're not functioning as an ecosystem in that area should, because a lot of people will see a pretty waterfall and a lake, and that's not really what those are going to function as, even though it visually may look like it. So I think a lot of times any pushback that we get stems from those concerns. And a lot of times when we can communicate the benefits from the dam removal, people are willing to listen, but there is always people that aren't necessarily supportive. And it's a lot of uh, trying to make sure that what's done is good for the environment, good for the people overall, and trying to just educate anyone who's coming along on the actual benefits, not just saying, and that's part of the reason we have data too. We won't don't just want to say, oh, well, we said it's good, so it's good. We want to show that this actual data is showing that once we removed the dam, there was these positive benefits to that dam removal.
Have you sampled for freshwater mussels and assessed their population changes?
We did do some sampling, biodiversity did some sampling around our dam removal sites, looking particularly when we were starting the dam removal sites, we wanted to make sure, because mussels can't necessarily move away from the construction and things like that. So we wanted to make sure there weren't populations that we were going to be endangering with these construction processes. And if there were in any places, we would move them. And so they have done these follow-up assessments of some of these mussel populations. There are endangered mussels, freshwater mussels in New Jersey, so they were also looking for things like that. Um, I believe in general there weren't any huge negative impacts on the mussels. I'm not 100% sure on their populations as a whole, but in their follow-ups, I know they did find mussels again after the dam was removed, but I don't know exactly how those populations would relate to other rivers or things like that. But it is something that was considered.
Okay. Up next, are there any volunteer opportunities around this work? And if so, how can people find out about it?
Absolutely. A lot of the volunteer opportunities now fall into that floodplain category. We are still removing about 28,000 tubes from trees along the Pollenskill. And so we do a lot of work with the Food Shed Alliance and us in particular, where we bring volunteers out and they will help us remove those tubes and prep them for recycling. If you're interested in some of that work, please email me. I'm happy to coordinate some of that. We do have some limitations on time of year with that work as these areas are not trails or anything like that. We're just walking through the woods. And so as it becomes more summertime, there's going to be lots of prickers and ticks and things like that to be concerned of. So we typically will do some of that through about May, maybe early June, and then we start it up again in the fall and do some over the winter. So if you're interested, please shoot me an email and I can let you know of any upcoming dates that we have, or even there's some sites that if you're interested in doing work on your own as well, we can train you and send you out into the floodplains to do that as well. Plenty of trees to steward.
Awesome, thank you. Are there economic benefits from recreation that we highlight when trying to get local support?
Absolutely. One of the big recreation things is being able to kayak in the area with these dam removals. There's a lot more open area for people to do kayaking, canoeing, and generally traveling along the river. Additionally, for anglers, these dam removals will often create new environments for them to be able to fish in, sometimes in areas like state-owned lands, so they're able to go on and fish openly. It'll often as well improve species presence, even outside of the migratory species. We see improvement of the resident species as well. So this opens up opportunities for them to catch something they maybe weren't catching before, in areas that they maybe weren't able to fish before. So there is a lot of recreational benefit and economic benefit from the standpoint of bringing people into these environments um, after the dam removal.
Thank you so much, Chloe. I believe that is all we have time for today. If you wouldn't mind going to the next slide, that would be great.
Absolutely.
Before we wrap up, I just wanted to quickly highlight the rest of our Earth Month webinar series. We have two final webinars taking place during the month of April that you definitely don't want to miss. The details are on the screen here, but I will also include a link to register for these webinars in that follow-up email that I have mentioned a million times at this point. So please be sure to keep an eye out for that email. I hope you can join us for these webinars. Again, thank you so much for tuning in today to learn about TNC's river restoration efforts in New Jersey. I hope you enjoyed the presentation as much as I did. Have a great day, and thank you so much for supporting the Nature Conservancy.